Hello, everyone. It's nice seeing you all here. So to introduce myself and also today's speaker. So my name is Tomáš Dominik. I'm an incoming postdoc to the Brain Institute at Chapman University, and I will be moderating today's event or tonight's event, depending on where you are. So the seminar is titled The Readiness Potential. What does it mean for conscious volition? And as always in the series, we have two speakers who will first give a joint talk, and after that, we'll have a Q&A section. In a minute, I will explain today's schedule in more detail, but before that, let me introduce today's speakers, who will be Aaron Schurger and Adina Roskies. So besides being one of the most substantial sources of my scientific inspiration, Aaron is an assistant professor at Chapman University, where he studies volition, consciousness, and other related concepts using methods like neuroimaging, behavioral psychophysics, and computational methods. While it is clear that Aaron represents the neuroscientific point of view today, it is not that much clear with Adina, who can be characterized as both a philosopher and a neuroscientist. Adina is a professor of philosophy at Dartmouth College who is engaged in fields including neuroimaging, philosophy of mind, philosophy of science, and ethics. And judging by images on her personal website, is also an airplane pilot and a mountain climber. So the seminar today will have two parts. The first part will be a joint presentation given by Adina and Aaron, and the second part will be a Q&A session. Please feel free to ask questions so that we can answer them in the second part. You can submit your questions at any time in the Q&A section, or you should see a Q&A button in the Zoom interface at the bottom of your screen, or you can simply raise your hand by clicking the raise hand button if you would prefer to ask the question aloud. I will do my best to sort the questions so that they fit the ongoing discussion. However, as always, there will probably be more questions than we'll be able to answer. So we apologize if we don't answer your particular question. In any case, we welcome your questions, so please don't feel discouraged by this. The seminar is planned for 90 minutes, so it's perhaps time for me to end the introduction here and give the word to Adina, who will begin the presentation on the role of readiness potential for conscious volition. So Adina, it's yours.
Can everyone see my screen? Yes? Okay.
Yes, we can see.
Yes.
Okay, great. So Aaron and I embarked on this joint venture because it seemed to us that a lot of the discussion about free will has focused on the Libet studies and the readiness potential. And we've gone way beyond the 1985 version of understanding what the readiness potential is. And we wanted to bring everybody up to date on where we think we are now in understanding the relevance of the readiness potential for volition and for free will. Why is this? Okay. So imagine you're standing on the diving board waiting to do your first Olympic dive, and you have to figure out when to jump. There's no external cue that's going to tell you when the right moment is. You have to listen to your body. And then at some point, you make a decision and you jump. For some reason, I'm not. I see. Okay. Okay, so you jump, and intuitively, we think that you decide before you jump. That is, at some point you make a conscious decision to jump, and following that, you jump. Work by Benjamin Libet. Does anyone know why my screen won't advance?
One thing, Adina, which sometimes helps with this is either you start the PowerPoint first and then you share second, or else it's the other way around. And I can't remember which one you've done and which one works, actually. But it has to be.
That's not the problem. The problem is you need to click on the screen and then your arrows will work.
Oh, okay. Ned, you're ahead of me.
Okay. All right. So what we think is, thank you, I think that helped. I think we decide to jump and then we jump. And it would be nice if the story were that simple, but evidence from neurophysiology had suggested otherwise. And Benjamin Libet in the 1980s had evidence that made him decide, or made him think, that what happens is actually your brain decides to jump first before you have any conscious awareness of your decision. And ultimately you become aware right before your body is going to jump that you're going to jump. So your brain gears up to jump, you decide after that, and then you jump. And that, he thought, posed a problem for free will. So very briefly, the plan for the talk is I'm going to first introduce this classic model. Many people are familiar with it, but I know that this is open to more than our group. And so I just want to run through the classic interpretation, and then I'm going to turn it over to Aaron, who's going to talk about further experimental characterization of the RP, including alternative models to the Libet model, or what I call the classic model. Then he'll turn it back to me for philosophical implications of this, and then I'll sum up. Okay, so what is the readiness potential? There's actually already a paper by that name by Shibasaki and Hallett that looked at this question about, well, more than a decade ago. But the readiness potential was first documented in '64 by Kornhuber and Dicke, and it was employed by Benjamin Libet in conjunction with a report of the timing of conscious volition, or timing of consciousness of intention. And because of the findings in his study, it became the center of a really large and ongoing literature regarding the question of free will, and more generally, the impact that neuroscience can have on philosophical questions. So just to review for people, the Libet paradigm is essentially recording from scalped potentials from EEG of somebody who's told to spontaneously move their finger or their wrist. And at the same time, you're also recording EMGs, so you're recording motor activity from the muscle. And at the same time that the person is doing this task, they're also looking at a clock and trying to time when they first become aware of the urge or volition to move. And so here on the lower left, you see the EEG cap. And in individual trials, what you see prior to the motion, the moment at which a person moves, is a very noisy but rising EEG trace that if you average over multiple trials, and this is very important because when we talk about the RP, we're always talking about these average trials that are time locked to the time of movement, you get this very characteristic ramping up called the readiness potential, which Libet said was preparatory activity for volitional movement. And what I'll call the Libet interpretation of the task is he conjoined this motion task with the EEG recording with this task where a person was supposed to look at a dot moving around a clock face and tell the experimenter after the movement at what point, where was the dot when he or she first became aware of willing to move or having made the decision to move. So the aim of this Libet study was to measure the time of the consciousness of willing, which he called the W time, relative to the time of neural signals that are related to action production. And Libet's findings, you got very widely dispersed W times, but on average, what he found is that the W time was about 200 milliseconds before a person moved, but the RP, the readiness potential, started at least 500 milliseconds before someone moved. And so Libet's interpretation was essentially that the brain decides before we do. So, whoops. Libet wrote, the brain evidently decides to initiate, or at the least prepare to initiate the act at a time before there's any reportable subjective awareness that such a decision has taken place. It's concluded that cerebral initiation, even of a spontaneous voluntary act of the kind studied here, can and usually does begin unconsciously. These considerations would appear to introduce certain constraints on the potential of the individual for initiation and acts. And so this brought to question the efficacy of consciousness in volition. So what I want to do here is just summarize Libet's results. People are probably familiar with this graph. What we're looking at are these spontaneous movements, so these type 2 RPs, where there is no pre-planning. And what you see is about 500 milliseconds before the onset of this rise of the RP, the motor activity first visible around M, and the person's judgment of when they became aware of willing was approximately 200 milliseconds prior to motion, so that's the W time. And so Libet, as I said, interpreted this as the brain decides to or gears up to jump, then we become aware consciously of the decision, and finally we jump. So what I want to pull out are 3 commitments of the classic view. First is that it is post-decisional. That is, the RP is neural evidence or follows upon a decision to move. The decision is taken typically to be at the onset of the deviation of the RP from baseline. The second is the RP is ontologically real, that it's a readout of a causally efficacious neural process. That is, that the RP commits one or leads to action, and that neural process has a distinct and measurable onset. And third is this interpretation that we decide non-consciously or unconsciously. So the RP, at least in these situations of spontaneous movement, precedes subjective consciousness of decision. Okay, and so this leads to the widely accepted doctrine that conscious will is inefficacious and therefore, with a little bit more philosophical commitment, not free. Now, critiques of the classic interpretation are many, and we won't discuss all of them, including many of the ones that focus on the reliability of the W timing. But just briefly, I can mention some classes of them. So one is the question of whether or not these experiments even probe the question of deciding whether or not to do something. Instead, the Libet paradigm really is more like the diving example, where you know you're going to jump off that board and the question is, when is it going to happen? So it's a when decision, not a what decision. Secondly, there's the point that many philosophers have made that simple motor acts aren't the right paradigm for investigations of free will. First of all, it's a mistake to think that complex actions are actually just the addition of simple basic actions. Secondly, there's the question that the decisions in the absence of reason are really not, at least arguably not, paradigmatic of free decisions. And Libet actually recognized this himself. So in his own paper, he wrote, in these voluntary actions that are not spontaneous and quickly performed, that is, in those which conscious deliberation of whether to act or of what alternative choice of action to take precedes an act, the possibilities for conscious initiation and control would not be excluded by the present evidence. So even he realized that his interpretation of non-conscious willing didn't undercut the possibility of free will writ large, but just in these very spontaneous movements. And finally, many have argued that longer timescales are the significant ones, for example, Gollwitzer. Furthermore, other studies since Libet have shown that the RP is not really reflective of having made a commitment to move. So that is actually one of the commitments of the classic view, that it reflects the outcome of a decision to move. But it's been shown that it's possible to withhold movement after an RP is initiated and develops to some extent, that the RP is even present in tasks that don't involve a motor component at all and only involve non-motor decisions, and even in tasks involving decisions not to move. And so the RP is not linked to some kind of ballistic signal to initiate action, but it does seem that all of these things are consistent with a different interpretation, which Aaron will talk about more, and that is that the RP is reflective of the decision process itself. Now, one thing that's worth mentioning is that typically philosophical debates about the freedom of the will have really revolved around the question of determinism and indeterminism. And there's something refreshing and insightful in this Libet line of study, because it really changes the focus of the free will debate from determinism to something about the role of consciousness in volition. there's still an aspect of determinism because his own interpretation required that the action follow the onset of the RP. So even if it's not deterministic, it's in some sense ballistic. But this shift from determinism to conscious will is in fact something that has inspired our entire project. And we think that there is something important to the intuition that free will, or at least something very closely tied to free will, moral responsibility, depends on our decisions being conscious or having conscious intentions. Now, this is a really interesting question, and I think people aren't very clear about what having a conscious intention or deciding consciously really means. And I'm not going to use the space here to explore that question, but we can ask whether the relevant type of consciousness is the type measured by the Libet task. And while there's very much to say about this, I'll at least point out one thing, which is that what the Libet task seems to measure, in fact, the W measurement, what it seems to be is a metastate whose content is a conscious decision or consciousness of intention, not the consciousness of intention itself, or not conscious intention itself. And if that's the case, then the W that Libet measures is not the W relevant to questions of free will. And in fact, the W relevant to questions of free will could happen anytime before the W time that he measures. So I think there's a real question, just completely disregarding alternative explanations or alternative models of free will and volition. There's a real question about whether by its own lights the Libet story is measuring something, some relevant variable in the question about conscious willing. Okay, so I think so far we've just given reasons to doubt that the Libet paradigm lets us know that we actually, our brains decide before we consciously decide to move. But in the next section, we're going to summarize empirical findings about the RP and talk about some new models that provide, I think, even more reason to be suspicious of all three of the commitments of the classic view that I laid out before: non-conscious, but also post-decisional and ontologically real. So I'm going to turn it over to Aaron, and I will swing back and talk to you guys later.
All right, does everybody see that?
Yep.
Making sure the technology is working. Okay, great. So just a quick review of what's, not all of it, but a sum of what's established about the RP. Trying to stick with the facts and not go beyond. The RP, sort of by definition, is a signal visible in the EEG or using other means of recording brain activity prior to spontaneous voluntary movement, when those time series are time locked to movement onset and averaged over multiple epochs. It exhibits significant variability across individuals. I'll show you that in a minute. It's quite difficult to resolve on single trials. Some might argue even impossible. And its temporal extent seems to be related to planning. So planned movements, for example, show an earlier initial rise. And it has at least 2 stages. At least, I would say. So looking here, going through some of these, I just pulled this up from a recent cohort of pilot subjects that we ran, just doing Libet's task. This is just to give you a flavor for the variability. So here are just 10 subjects, and these are their individual readiness potentials. And what's interesting about these is just how highly variable they are, and maybe only one of them, to my eye, subject 7, exhibits something that looks very much like a canonical readiness potential. Subject 4 seemed to have a problem with his electrode that day. But if you look at the other subjects, you can just see how variable the shape of these is. Subject 5, for example, doesn't really exhibit much of a readiness potential at all, except for the very final bit that we usually attribute to the burst of activity in primary motor cortex. Does that mean that subject 5 has more free will than the rest of us? I don't know. But another thing is, if you look at the group average, you see now something that looks quite nice. It looks like a canonical readiness potential that actually results from averaging all of these other signals. few or none of which actually look like that group average. The RP is notoriously difficult to resolve in single trials. So here I've just shown from one example subject what things look like when you have one trial or the average over 10, 50, or finally 200 trials. It isn't until you get upwards in the tens of trials that you can actually see something that starts to look like a readiness potential. Here is just something showing you the relative amplitude of the signal versus the noise. So in white there you have, these are the raw individual trials, and then the black line down the middle, that's the actual resulting readiness potential from averaging it all together. So this really is a very weak little signal buried in a lot of noise that we see by and large only after averaging a lot of trials. I don't mean to say that it's utterly impossible to resolve it on single trials. If you play some signal processing tricks, you can to some degree, but it's quite challenging. I mentioned also that the readiness potential has two different stages, at least two stages. People have debated this a little bit in the past. It has an early stage that's thought to reflect subcortical to pre-SMA or activity in pre-SMA and other areas of premotor cortex. And this is activity that might be shared or similar to processes reflected in other slow potentials like the CNV and the SPN, which I'll talk about in a moment. And then there's a late stage, more tied to motor processes. I didn't actually mark the line between these two stages here because there are still different theorists, different researchers kind of draw the line in different places. But typically, I don't know if you can see my mouse, let me see, laser pointer, there we go. Typically, this early stage is quite long and slow, and then the latter stage, which happens in the last at least 300 milliseconds before movement, is a bit more abrupt. And that's the point in time, by the way, when the signal starts to become more lateralized. The amplitude of the RP, it's greater in faster paced movements, for example. It's greater with more complex movements or when more force is required. And the amplitude also seems to be modulated by non-motoric factors, for example, such as attention. The temporal extent of the RP is highly variable. I can't emphasize that enough. It really depends a lot on how you measure it, who you measure it from, and when you measure it. Depends quite a bit on task as well, and the kind of filtering that you do. Here, we didn't do any kind of filtering. If you look below, these are magnetoencephalography traces or MEG traces from subjects performing Libet's task. What you see on the left and the right are just from two different types of MEG sensors called magnetometers and gradiometers. These both tell a similar story, though. You can see the burst of motor activity right at time 0 when the movement actually happens. But you can see that this gradual change in neural activity stretches back at least 2 seconds in this case. So the RP then leaves us with some puzzling questions, right? Not all subjects exhibit it. Anecdotally, if you ask a researcher who studies this, we all know that when you run a study, upwards of 20% of your subjects sometimes just don't really show much of a readiness potential, although they can quite well do the task. We still don't know why. The shape and the onset of the RP are also highly variable. And importantly, the RP has so far not proven to be a very good predictor of movement onset when people have tried to use it, for example, as the basis for a brain-computer interface. And again, I should qualify that. I say it has not proven to be a very good predictor. That doesn't mean that it's not a predictor at all. It does predict better than chance. It just doesn't predict particularly well. it doesn't predict as well as you would hope it would, given the assumption that it's the brain gearing up to generate a movement. One of the reasons conceptually that the RP may not be such a good predictor of movement is, again, comes back to this important fact that it's something that we observe and that we learn about by time locking to the onset of the movement. So we typically, again, we event lock our data to the onset of the movement itself, and then extract epochs from the data and average those together. That's how we study and learn about the readiness potential. So imagine, to draw an analogy to weather forecasting, imagine trying to learn how to forecast the onset of rainfall based on a sample of only rainy days. Right? This would be a highly biased sort of sample, and you might have trouble learning. In fact, in the end, you might have trouble doing a good job of predicting the onset of rainfall, because very often it doesn't rain. So likewise, with the way we study the readiness potential, we always look at data samples where a movement actually happens. By definition, that's how we know what data epochs to extract. So other interpretive difficulties with the readiness potential, we know of two other slow negative going potentials that on the surface look very much like the readiness potential in terms of their temporal and spatial profile. One is called the contingent negative variation, or CNV, which is observed when a pre-cue predicts the onset of an upcoming imperative cue. So you have a cue that says, get ready because the real cue is coming in exactly 1 or 2 seconds. And during those 1 or 2 seconds, you see a slow buildup that peaks right at the time when the imperative cue is going to appear, telling you, okay, press the button now. So in fact, you could make a good argument that we should actually call the contingent negative variation the readiness potential, because it really is a signal of you getting ready, right? It's what you get when a cue appears saying, get ready to move. The other is called the stimulus preceding negativity, or SPN, and it's present without any motor response, without you making any movement at all. It's a slow buildup that happens just when you're expecting or anticipating the appearance of a stimulus. And remember that this is just a stimulus that you're going to observe. It's not a cue telling you to move. So importantly, these, including the readiness potential, are mainly distinguished by the paradigms by which they are elicited. And so they may share some neural components. We'll focus here briefly just on one of those, the stimulus preceding negativity, or SPN. Here are traces from a paradigm where the subject performs a self-paced movement, here in time indicated by this arrow, and you see a nice readiness potential that's lateralized. The subject here, in this case, using the right hand. And then immediately following that, the subject knows that after a very specific amount of time, I think in this case, 2.5 seconds, you'll have a feedback stimulus. And lo and behold, while you're waiting for the feedback stimulus to happen, you see a very similar looking buildup. Of course, this large peak here, this large response here, this is the response to the stimulus itself. But you see a buildup that looks very similar to the RP, although it's not as lateralized. So we've, I won't have much time to get into this, but we've recently been conducting a study where we were trying to control for anticipation. And so we use machine learning in a sliding window to try and, in a sense, predict the onset of movement. And we do that under two different circumstances, one where we haven't controlled for anticipation, and one where we've matched the movement and non-movement data for anticipation. And what you can see here is in 3 subjects who came back for several sessions, we were able to, this time axis here shows you the time of the leading edge of the sliding window, we're able to sort of predict the difference between movement and non-movement quite well when we don't control for anticipation. But that ability collapses, you can see by looking at the yellow traces, when we control for anticipation. So this suggests that the RP may, in fact, a fair proportion of the variance in the readiness potential might be accounted for simply by anticipation. What would you be anticipating? Well, it stands to reason that you're anticipating your own movement, the proprioceptive and sensory consequences of that movement. That's something that you really can't get around. Every time you make a self-initiated movement, the brain probably can't help but try to predict, right, the somatosensory, proprioceptive, and sensory consequences of that movement. So I've been talking so far, and we've been talking so far about the readiness potential. I just want to point out that depending on how we measure it, we actually give it a different name. When we measure it using magnetoencephalography, or MEG, it's called the readiness field. When we measure it as an increase or a buildup in firing rate in single neurons, we call it a readiness discharge. I'd like to switch to, for the rest of the talk, a different moniker, just calling this the PMB, or pre-movement buildup. These are just different ways, right, of measuring the same underlying phenomenon, which fundamentally is a buildup in neural activity, in the firing rate of populations of neurons. So we know that this pre-movement buildup is not just an EEG thing, right? We know that thanks to these very nice data from 2011 from Itzhak Fried et al. They recorded from people who were being monitored for epilepsy, and while they're in the hospital being monitored, they have electrodes implanted in their brain. We can ask their permission to record from those electrodes. These subjects were asked to do Libet's task, and to make a long story very short, you can see here that there's a buildup, in fact, in single unit firing rate preceding the moment at which they make this spontaneous movement in Libet's task. The pre-movement buildup is not just something that's specific to humans. We've identified it also in primates and rodents, and even in invertebrates like the crayfish. So this buildup of activity that happens at the moment of a behavioral state transition, where you sort of transition from waiting or resting to acting. So as Adina mentioned, the past few decades have been dominated by sort of what she called the classical account of the readiness potential. More recently, we introduced a different account based on the idea of what's known as a stochastic accumulator model in perceptual decision-making research. So basically, to unpack that, to briefly go over that account of the readiness potential, the idea here is that you have in blue a threshold, which is the threshold for initiating the movement. And just below that threshold, you have a signal that's varying more or less randomly. It has a slight trajectory towards the threshold that's given by the demand characteristics of the task. But the precise time at which the threshold is crossed, rather than being primarily driven by this imperative to move, this weak imperative to move, is mainly determined by these subthreshold ongoing random fluctuations in brain activity. And because of that, when we time lock to the moment of movement onset, then we recover the characteristics of the noise that will end up looking like a gradual buildup. So we took this idea and we're able to use a very simple mathematical model. Again, this is called a leaky stochastic accumulator. It's been used for decades in research on perceptual decision making. The idea here is that when the imperative to move is weak or absent, again, the precise time at which the threshold is crossed leading to movement onset is largely determined by these sub-threshold random fluctuations in neural activity. And if we time lock to the moment of that threshold crossing and average together, we recover something here that looks very much like the shape of the readiness potential. And we're also able to account very nicely for the distribution of waiting times, how long subjects wait in Libet's task, by the distribution of first crossing times of the threshold in the model. So this particular view of things makes a number of different predictions. I just want to highlight one of them, which is what it says about different constraints on the time of movement. An important idea from this model is that the role of non-goal directed influences, these sub-threshold random fluctuations in brain activity, should be increasingly prominent as you moved from circumstances where the time of movement is highly constrained, like trying to hit this baseball that's thrown at you, to a situation where the precise time of movement onset is relatively unconstrained. For example, trying to hit this baseball that's just perched on a stick. This is much more like the diving board example that Adina started with, where the time to initiate the movement is up to you. Adina also mentioned this distinction between a pre-decisional and a post-decisional account. So now that I've covered this stochastic accumulator account, I just want to point out that it is in fact a pre-decisional account of the readiness potential. It suggests that what the signal that we recover in the average and call the readiness potential actually reflects activity that's antecedent to the decision to move. Whereas the classic Libet account suggests that the decision to move happens very early in time and that the readiness potential reflects a process that is after, that is a consequence of that decision. So there's been some converging evidence in favor of a pre-decisional account. I list some of it here. The idea, again, behind the pre-decisional account is that this early part of the readiness potential reflects spontaneous ongoing fluctuations in neural activity, and that the neural decision to move happens relatively late in the game. We estimate at around 150 milliseconds before movement onset. So I mentioned before about where to draw the line between the two different phases of the readiness potential. So based on this account of the readiness potential, this is roughly where we draw the line. At about 150 milliseconds before movement is where the actual quote unquote decision to initiate movement takes place. So there's been some other evidence, however, just to be fair, consistent with a post-decisional account. Kaleginejad et al. In 2018 showed a process of noise reduction preceding spontaneous voluntary movement. This suggests at least that the brain maybe is getting ready to do something or gearing up to do something. However, it's difficult to pin down as being necessarily pre or post-decisional account. Travers et al. In 2020 also asked the question, do RPs happen all the time? If we are to buy into this pre-decisional or stochastic account, then that suggests that RPs may happen all the time and just don't quite make it to the threshold. And so the answer there is, well, yes and no. RP-like events, of course, will occur in any data set containing the 1/f noise ubiquitous in EEG recordings. So I think all in all, the word is still out as to which account is the true account. However, I think the stochastic account has in its favor that it's parsimonious, and it's, I think, the one that you have to contend with before switching to other less parsimonious accounts. There are some other pre-decisional accounts in the works. One that I'm working on currently is based on the idea of motor rehearsal. So this is simply the idea that, again, we have these spontaneous ongoing fluctuations in neural activity. And while we're doing a task like Libet's task, we have these little moments where the brain says, well, maybe I'll move now, or maybe I won't. Well, maybe I'll move now, or maybe I'll move now. These are what I call little motor rehearsal events, and that the movement actually happens when the sum of the motor rehearsal events, of one of those events, and the underlying fluctuations cross the threshold. And again, using this kind of model, you can nicely reproduce the shape of the readiness potential and the distribution of waiting times in the Libet's task. There's also Adina's what we call bumps model, which basically is similar in some ways, suggests that we have these volitional events that happen at a certain rate, somewhat randomly, and that the temporal integral over those, when that temporal integral crosses threshold, we initiate the movement, and that the noise in this case comes in the form of the rate of those volitional impulses. There's also the catching the waves model from Schmidt et al. The idea is that voluntary movement is more likely during the negative phase of the slow cortical potential than the positive phase. Again, also very similar in spirit to the stochastic accumulator model. So just two last points, and then I'll turn it over to Adina. Why is the RP, or the pre-movement buildup, difficult to interpret? There are a few reasons for this. I'd just like to talk briefly about one of those. So here we have two different kinds of event-related potentials, right? Here on the bottom, we have a visual evoked potential, which is known as an event following potential. So there's a stimulus event, a stimulus appears, and now we look at what happens in the brain, notably in visual cortex, in response to the stimulus, so following the event. Here we have an event preceding potential. This is the readiness potential. Here we allow the subject to initiate a movement. The event here is the movement itself, and we're looking at what's happening in time in advance, so preceding that event. And the important point here is that not all event-related potentials are created equal. These are not just different in the sense that one comes before and one comes after. They're fundamentally different in a different way, in a very important way. With an event following potential, the onset time of the event, the stimulus, is determined by the experimenter. And we tend, in most studies, unless we're specifically interested in pre-stimulus effects, we tend to randomize the onset time of the stimulus so that nobody knows when it's going to happen. So it's so we can be sure that it's independent of what's ongoing. In the case of an event preceding potential, like the readiness potential, the same system, which in this case is the brain that is generating the signal, is also determining the onset time of the event, the movement. Well, that changes everything. And so one of the consequences of that is that activity that may or may not be causally related to the onset of the movement can get thrown into the mix. We just don't know. And so this is one of the reasons that I've been strongly advocating for and currently working on switching to time unlocked methods of studying pre-movement activity. So with the classical readiness potential, we take many, many trials, we time lock them to movement, we average them together, and we get an estimate of the probability of the signal given a movement at time 0. And what we're working on is a different method where we look at the entire data set, we look at the entire time series, and we try to estimate the probability of a movement in the future given the signal now and in its recent past. And that gives us a distribution that, at least for a stochastic process, looks like what you see here in blue. And it's something that we can we can use, for example, that this distribution looks different for a stochastic process and a deterministic process, for example. What's good about this, and this is not the only way to do time unlocked analyses, but it's one way. And what's important is that it takes into account all of the data. When you're moving, when you're not moving, it looks at the entire time series and tries to understand really what is genuinely predictive, what is not just antecedent to, but is predictive of the onset of movement in continuous time. So Adina, you can just, I think, ask to share the screen and it will steal it from me.
Yep, I am doing that. Can you see it?
Yep.
Yes,
Okay.
we can.
Great. All right, so thanks, Aaron. I wanted to now just sort of consider the philosophical and scientific implications of the stochastic models. So as Aaron explained, the stochastic models are pre-decisional. So where the RP is already detectable, the implication is that there's no decision yet to move. And that changes the way in which we interpret the relative timing of W and decisions to move, or conscious awareness to move, and the brain activity. So the RP under the stochastic model may reflect the buildup of a signal, which either a signal of which the agent becomes aware around W, or that is causally connected to becoming aware of a signal. Many have suggested that consciousness is a process and it is a temporally extended process. There are some works that suggest that the W timing is not related to the buildup, but I think that it's still an open question. Another thing to notice is that the RP is a kind of artifact. It emerges from biased sampling by averaging these traces that are time locked to an action. We don't see what happens when an action doesn't occur. So it doesn't necessarily reflect an underlying neural process that's present only prior to the action. As Aaron said, there could be little RPs all the time, although nothing that has the profile of the RP has been found. Many different kinds of signals can be averaged to get something that in aggregate looks like an RP. So these excursions that are close to bound may frequently occur without crossing threshold and leading to action. If that's the case, then there's really no physiological significance to the onset, to the notion of an onset of the RP. The RP onset can't cause anything or reflect anything because it's not a real causal process. And as I mentioned, in some of these other models with motor activity or the bumps volitional model, you get the RP signal emerging from what are potential real signals as well, not just noise. So the stochastic models negate all three, I think, commitments of the classic view. The post-decisional commitment that the RP is neural evidence or follows upon a decision to move. It's now a pre-decisional model. The RP reflects evidence that contributes to a decision to move. From thinking of the RP as ontologically real, we think of the RP now as somewhat artifactual. It's a sampling bias. The underlying signal has no measurable onset, and the signal that is there in individual trials may not resemble the RP at all. And inferentially, all we can infer from this is that if there's an action, then in aggregate you get an RP, but you can't infer from the RP to the necessity of action. And third, that it's non-conscious. Clearly that's not the case under the accumulator model. It may reflect a signal. It gives rise to subjective consciousness of either decision or having an intention. So how do we connect this new way of looking at the RP to the free will debate? Well, first of all, quite obviously, if there's no sense to be made of the RP onset, then there's also no sense to be made of the relative timing of that onset to W time. So that, I think, undercuts the Libet style arguments for unconscious decisions leading to action. The decision in these kind of spontaneous movement Libet style tasks under the accumulator model that Aaron presented is due to noise. Now, I don't think that this is a real challenge to free will, because you can think that in cases where you are not given any kind of consideration for or against acting at a particular point, you might think that it's perfectly appropriate to just let decisions happen using whatever means you have at your disposal, whether it's noise or something else. So I think in this particular paradigm, there's little threat to the conception of free will, but not all philosophers have to agree with that. So I think that when you start thinking about the relationship of the accumulator model with crossings due to noise and the way in which they interact with some philosophical positions, it's not entirely straightforward. So if you're an agent causation theorist where you think that the action has to somehow stem from the agent, then you might think that the fact that the action is causally dependent on the noise level might not satisfy that agent causation theorist. On the other hand, it would satisfy most libertarians, people who think that freedom is secured by indeterminism, if it turns out that the noise is indeterministic, and we don't really have the answer to that. And then I think most compatibilists would find the accumulator model very congenial. So in this case, we can distinguish between random decisions, like decisions in the Libet style cases where there's no particular reason to move at any time. And noise may effectively allow us to make decisions with a random character, but that doesn't have any clear implications to free will or responsibility in other types of decisions, such as decisions for reasons. And even in Aaron's accumulator model, where the threshold crossing is primarily due to noise, it's still a deviation. It rides on a deviation from the baseline that has some kind of volitional meaning. And so if that deviation from the baseline is intentional or conscious, there's still an aspect of that model that is related to volition. The other stochastic models that Aaron introduced are, I think, more clearly related to volition. That is, the threshold crossings are more directly tied to signals that reflect some kind of volitional process, either motivational strength in the bumps model or motor ideation in the motor rehearsal model. And then I think the interpretation could be more agent-centered than noise-centered in these kinds of models. And I think that this partial volitional component may still be enough to secure agency or free will for these kinds of decisions, even for an agent causation theorist. And I just want to mention that, you know, no one's seriously suggested that in order for us to act freely, we have to be aware of all the causal influences on our decisions. And there's evidence in these Libet tasks, which are supposed to be emblematic or paradigmatic of free actions, that there are clear biases and constraints. And so you can see that the trial time in in trial n and n+1 are highly correlated. And then in the rightward thing, you can see that the mean stop time for subjects seems to be biased towards the bottom of the clock for reasons we don't understand. And then in the other traces, what you can see is that the stop time seems to be tied to the inhalation and expiration, or inspiration and expiration cycle of breathing. And so these are influences on our decisions or our at least judgments of timing that don't seem to be tied to volitional processes, but nonetheless affect them. But I still think that that doesn't undercut the possibility that these are free actions of a sort. So, and I think that the catching the waves model the idea that there are low frequency signals that bias the likelihood of movement is just one of these. There's evidence in the Schmidt paper that even though the movements are biased by the slow cortical potentials, they don't necessitate them. So a third of the time, movements occur during the positive going low frequency waves. And so this model is also consistent with the drift decision model. It's, I think, not undercutting the notion that you can make decisions with an accumulator type model that are free, even if they're not unconstrained or due to non-volitional processes in some degree. I think there's also a methodological take-home for this. So there are many studies that have been done recently and not so recently that use the RP as some kind of experimental construct. And there is a question if we think that the RP is really artifactual, is that okay? Can we do that? And I think the answer is still yes, but I think you have to be careful about when you use the RP and how you interpret it. So if there's no RP in single trials, you could still use the RP as a temporal marker in aggregate because it reliably precedes voluntary action, although, as Aaron said, it's not a good predictor of the timing of voluntary action. We know that movement is more likely when the underlying activity is closer to threshold, and so that seems like something that is completely legitimate to measure. But I think that care has to be taken not to infer from talking about and using the RP that it reflects an actual brain signal that looks RP-like in individual trials and a brain signal that has causal efficacy. So just to summarize, the classic or post-decisional models assume that the RP onset has physiological significance. And because of that, they open up a space for comparisons between the onset time and the time at which we are conscious of willing, and therefore for arguments about the inefficaciousness of conscious will. But I think that a family of stochastic models can also and equally well model the RP. And under these models, the RP is a natural consequence only of our analysis techniques. It doesn't entail that there's an electrical potential with the characteristics of the RP that signifies action initiation. Instead, all it is reflective of is the fact that there are underlying decision processes that are giving rise to decisions that probably happen much closer to the time of action, and maybe approximately exactly when we're aware of them occurring. None of these models, I think, challenges the efficacy of conscious will, but as I explained, some of the model details might influence the way in which decisions, awareness of decisions, and other philosophical commitments might be related. But at this point, I think Aaron and I both advocate intellectual humility. I think there are many things we don't understand about the RP and the signals that are underlying conscious volition. And I think a whole family of possibilities is still in the air. So, I mean, it's pretty clear that the brain is doing something before we act. It's pretty clear that we decide consciously before we act, but what the relationship between the brain preparation and conscious decisions are, I think, is still quite up in the air. Although I personally think that the processes that underlying decisions and conscious decisions and our actions are not causally unrelated, I think there's still room for that. But to me, I think the evidence points much more to a decision-making mechanism that leads to awareness of our decision prior to action, but not an early decisional model that precedes consciousness. So with that, I will conclude and we'll open it up for questions. Thanks very much.
So thank you, Adina. Thank you, Aaron. I think we can all clap. I'm not sure whether we can share the emoticons here. So thank you very much for an inspiring talk. I think I might need to restrain myself from asking too much questions myself and give way to our attendees. So I see a few raised hands, but we also have a few written questions, which I would maybe get off our plate first. And the first one is from Walter, but I guess a significant part of this question was already answered by Adina's second talk. So the question was, does the stochastic accumulation model undermine free will and conscious control? How can we be free and in control if our acts result from a process that is stochastic? And then he added and unconscious. So this might be a question equally distributed between Aaron and Adina. So if you want to add something to it.
You want to know if I want to add something to it?
No, I meant Aaron and Adina, but Walter, if you have some clarification, feel free.
And because Adina did address this after I put the question in the chat, so I'll just add, I don't think it helps to say, well, these arbitrary decisions where nothing hinges on it and we don't have a reason, that's not really the central issue, because that's not the issue for responsibility, because if it's truly arbitrary, there's nothing to be responsible for. But it is the issue for free will. I mean, you ended with a picture of Buridan's ass, and that has been the kind of paradigm case of free choice. If you tell me, well, I'm not free to pick the cereal box to the left or the cereal box to the right, I think most people would be extremely surprised. So I want to know how the stochastic accumulator model yields control for the person in a situation like that, just to make it more specific and concrete, because it sounds to me like it's a stochastic process that's occurring. Maybe it causes me to be conscious, but it occurs before I'm conscious. And whether I become conscious and whether I decide, seems to be the result of those earlier things. So I don't see how that gets you freedom or control.
So I think so suppose what you're seeing, the RP, reflects a process that leads to consciousness and to decision making. Now, I'm assuming that we're not dualists, that we're naturalists, and that we think that anything that the mind is going to do is going to have some underlying brain stuff, right? So if you're looking at the underlying brain stuff that, let's say, contributes to both your decision and your conscious awareness of the nature of your decision, then it seems to me that there isn't a problem, right? When activity, in these cases where there's no imperative to decide one way or the other, the volitional aspect, I think, comes in where you're deflecting close enough to threshold that so the exact moment of when is something that in essence you give up to your internal random number generator. That doesn't seem to me to undermine freedom, and also because these are cases in which you can imagine there are lots of signals you could potentially listen to, but it doesn't matter. You just need to listen to a signal, so let it be noise. And that noise potentially could be reflective of some other volitional thing elsewhere in the circuit that we don't know from this kind of work. But I don't even think that's necessary to secure free will in these cases. As Aaron showed, can I just say, Aaron showed that picture with the baseball, right? Where there are decisions in which it matters when you act, right? In those cases, the underlying processes that drive your action may also well be volitional, right? You might swing the bat for a reason because the ball is coming to you now. And you may very well intend to, want to, etc. These Libet style cases are a particular case where the fact that the exact moment of when you decide may be noisy, I think you can't infer from, let's say, the fact that that happens in these cases, that all decisions that that you make are governed by noise, right? And in some of these other models, like the bumps model, the decision is governed by your motivation to act, right? How much impetus do you have to act now? That could very well be a volitional signal.
Yeah, I mean, I totally agree with that. That's a different kind of case. But in the case where it's random and you don't have any reason, if somebody told me, hey, there's a random number generator in your brain, and when it comes up with even, you go left, and it comes up with odd, you go right, I wouldn't be upset because if they're equally good, but I would be upset that I'm not in control. This random number generator is what's making me go left or right.
Well,
Yeah.
I think, oh, sorry, Adina.
Go ahead.
I think what you're saying, Walter, is that there just isn't the right kind of task. That this at least not the accumulator model in general, but this stochastic accumulator idea is really meant to account for a situation where the imperative to move or the reason for moving is absent or really weak. And that may be the wrong kind of context if you want to ask questions about quote unquote free will, because I mean, yeah, as the baseball example showed you, I tried to show was that as things are more determined by a reason, then those stochastic fluctuations should play less of a role. But then you run into a philosophical question that I don't know how to answer, but that, you know, now you have this reason for moving, which is, say, the baseball coming at you, but then you're not free there either because your time of your movement is determined by this external stimulus.
I want to just, I mean, I think in a way you've sold your model short, Aaron, because it's the very same underlying model that would, well, that I think would govern decisions for reason. So Walter, if you were trying to decide, do I move right or left, you know, you have this random number generator, and I said, but I'll give you a penny to move right. Then you could move right and be under control because there would be evidence going into that decision model that would bias the outcome, right? That would be the,
if a penny changed it from 50-50 of going right and left to 80-20 of going right and left, but still which way I went was just due to a random number generator, I don't think I would be in control.
Okay, I guess I disagree. I think you're in control as much as you need to be in that case. And the fact that in a counterfactual situation, you know, some tiny thing could nudge you 100% of the way in one direction, I think that you're in control. So maybe the thing to do is say, well, what would happen in these counterfactual cases? Right?
Yeah, but that's not shown by any of the experiments or the models or.
No, but I think it's consistent with them, and it's consistent with an underlying decision model, right? So those models can take into account the force of evidence or reasons and give, you know, and you could be in control, right? If those reasons are reasons you care about, they are the things that allow you to move in one direction or the other. But in the absence of any reason, you can pay attention to whatever signal, right? I think, and maybe it's at that higher level that you get to exert control, right? You can override the random number generator.
Maybe, we just know how that works, but I want to be quiet and let other people talk.
Yeah.
Yeah, I think, I mean, just to wrap this up, I think one of the important things about the accumulator model is that it's not so much that it doesn't give us anything in the way of free will, one yes or no. It just suggests that prior evidence, namely the readiness potential itself, that we thought was evidence against the possibility of free will, doesn't really count as evidence against. And so that doesn't give us free will, but it says, well, back, in a sense, back to the drawing board. I mean, one of the things it suggests, for example, is that the time of the onset, quote unquote, onset of the readiness potential doesn't mean anything. There is no onset, right? This is something that the idea is that this is just a reflection of the sort of fingerprint of the noise, of the character of the noise in the data, that just stretches back in time in a sort of asymptotic sort of way. So, you know, how early it, quote unquote, begins just depends on how many trials you average together. It's sort of like in the weather example, the onset of rainfall is something that you could reasonably call an event. But what about the fall in barometric pressure that precedes the rainfall? When did that start? Well, that's a lot harder to say, right? You can, I guess, you can probably come up with some arbitrary sort of rules to say when that starts, but in a similar way with the readiness potential, we could say, well, at some point there's a threshold crossing, which is a decision to actually really initiate the movement now, but this process that builds up to that, it's hard to say when that begins. And so using that as a temporal marker is maybe not the right way to go.
Okay, I suggest that we have a lot of other questions, but we can eventually get back to this topic because we also have a few follow-ups from different authors. But right now, I would have two other questions for Aaron from Liad, because these are rather clarification questions. So the first one is, in the study where anticipation was controlled, was there an RP irrespective of decoding in the two conditions?
Good question. Yes, there was. I mean, I wouldn't call it an RP, but there was a shallow buildup in both cases. Yes. Yeah, there was a shallow buildup. You know, at certain sensors. Yes, roughly where you'd expect it to be.
Okay, so we have that clarification. And then there's another question from Liat. In the updated account, including the motor rehearsals, could you please elaborate more about the meaning of these rehearsals or the mechanisms that generate them?
Sure. So the idea for the motor rehearsal account really came from introspection at first. Was that I think a lot of, not just introspection, but also interviewing subjects, that a lot of subjects report when they do this task, they report something like kind of rocking back and forth between moving and not moving. So they kind of, at random times, or at least seemingly random times, they think, I wonder if I'll move now. Maybe not. Or I wonder if I'll move now. So they consider moving at many, many times throughout each epoch, and then one of those actually comes to fruition. So that's the sort of introspective view that just led from this to the idea in the first place. The idea there is that maybe there are sort of repetitive bursts of activity in the motor system that are sort of themselves not quite enough to actually cause the movement to happen, but the interaction between those and some underlying fluctuations is enough to drive the system over a threshold. So it's a way, if you ask a brain to do Libet's task, it has, well, subjects do the task, right? They do it. They say it's weird. Everybody says it's a weird task. I agree it's a weird task, but subjects do it. And they get the hang of it. They say, oh yeah, I get the hang of it after a while. So how does a brain do it? Well, one way, like the simple stochastic account, is like just kind of boost your signal up close to threshold and then wait. That's one solution, right? Another solution, again, is to sort of have these motor rehearsal events every so often and wait for a coincidence between one of those and the subthreshold fluctuations. That works too. That gets the job done. I don't know which is right.
Thank you. And thank you both. It's been a fascinating session. Thanks.
You're welcome.
Okay, thank you, Aaron. Thank you, Liad. Next, Patrick has raised hand for a long time, and after that, I will read a few questions from Tim Hicks, which will pertain self-experience. So, Patrick first. Patrick, you can unmute yourself.
Thanks very much. You've caught me eating peanuts, so I have my mouth full, so excuse me.
Oh, sorry.
It's getting towards dinner time here, so I'm snacking. Well, thanks very much. I really enjoyed the presentation. I found it extremely interesting and very clear. And there's lots to like and lots to agree with. And I just want to raise a couple of questions which are both chronometric. So Adina, you quite correctly questioned whether we should still accept any arguments relating W time to RP onset, right? That was the form that the original temporal precedence argument of Libet had. And since we shouldn't really assume that there is any such thing as RP onset, we should therefore doubt those arguments. And I think my point is that sometimes you can relate W to something else, namely the time of the movement itself. And that is quite important and quite interesting, because there's an argument from post-diction which suggests that all of our awareness of our intentions or our experience of what we're about to do is retrospectively confabulated after we've done it and retro-inserted into our stream of consciousness. So on that view, we don't really have any conscious experience at all of will or anything before we move. And therefore, if one can find some way to relate our conscious experiences chronometrically to movements, that is already informative. So if you can demonstrate that there's a conscious experience which is movement related before the movement has occurred, then that's useful. Now it's a different question. It's not the question of whether there's causally efficacious will. It's the question of whether all experience of action is confabulated, but it's related. So that's one thing. And then if I could perhaps have a second question, which is to both of you. You talked about pre-decisional, and I guess my own terminology would be a little bit different. So I think that one can often separate accounts of volition into those that are based on early decisions and those that are based on late decisions. And the accumulator model that you're suggesting here, I think, is very much a late decision model, because you think that the neural decision is made when the noise takes you up to the threshold, and that the apparent decision to begin an RP is actually nothing of the kind, because there is no thing to be decided. There is no beginning of the RP. So I think the question really is about whether you want to have an early decision model or a late decision model. Now, right back in the 80s, people said to Libet, well, maybe the real decision is not related to the action or the RP, but the decision to do the experiment. And within some accumulator models, there is a kind of a hint or a ghost of an early decision, which is the preliminary adjustment of the baseline to take you close enough to threshold that you will actually, reach it at some point. So I think calling the accumulator decision model a late decision model is perhaps a little bit too strong. I think there's probably an early decision there which is just less visible and less recordable and less accessible to the kinds of things we study in experiments. And this is a comment which was made equally back in the 80s to Libet, but I think it may also apply to the accumulator models that we use now. So those are my two comments. Thank you very much.
Why don't you go ahead, Adina?
Okay, I wasn't sure whether they were questions or comments. I mean, I don't have, personally, I don't think very much rides on whether you say early and late versus pre or post decisional, because we don't know exactly how, I mean, if we knew how to identify the decision, we could actually say that, right? But I agree. I think there may be numerous decisions that are made, including, whether to participate in the experiment, whether to listen to the instructions, maybe how frequently, some sort of baseline that governs how frequently you're going to move. So I think you're right. There's not a single decision at work there. But I guess if the decision is when to move, that's what the accumulator model, the part that we were talking about, is about. But I agree. I think that there's a much longer term, and I would say very likely conscious volitional decision to bias the baseline such that you end up performing the task. So it's overly simplistic to boil the Libet study down into a single decision. I agree with that.
Yeah, and I say, just to clarify, Patrick, that yes, so the stochastic accumulator model has both of those components in it. It's not, you know, some have suggested, oh, well, that, you know, my actions are entirely random or whatever. Well, no, I mean, the model, what's different about this stochastic accumulator model, or there's nothing different about it, but what's different about the way that I've used the model, is that I've used it in a context or in a regime where the quote unquote evidence in the model is very small compared to the noise. And so, but that evidence is there, and it's there intentionally. It's in order to account for the demand characteristics of the task, and just like you said, the commitment to do the task in the first place. So, you know, subjects come in, and you tell them that they can wait as long as they want to move, and that means that they don't. I mean, technically, that means they don't have to move at all, but they always do move. You know, they don't wait, they never wait too long, even though you tell them explicitly that, you know, they can wait as long as they want. There is this demand characteristic, and that's in the model. That's, you know, when I showed the plot of the lines crossing threshold, I mean, there's one line which is just this very subtle imperative to move. That's the demand characteristics of the task. That brings you up closer to threshold. And then spontaneous fluctuations, according to the model, again, actually determine the precise moment at which you move. But had you imagine in a perfectly noiseless system, you would eventually cross the threshold according to the model.
Yeah, thanks very much. I think your explanation is very strong. I think you clearly say that you're aiming primarily to provide an account of when people move. And I wonder whether that generalizes unproblematically to the other decisions that we care about. So sometimes we do really care about when we do things, but sometimes when we do something seems less important than what we do. So I don't know whether the same writ will run for what decisions and for whether decisions. I suppose it might. They tend to be fairly interchangeable in a DDM model.
Yeah, you can certainly use the same kind of model to account for what decisions as well. You certainly can, yeah.
The LIP work with you know, eye movements on the basis of evidence is using the very same model, but there you have evidence that drives the model, except in very, very noisy situations. You know, if you have zero evidence, the monkey still chooses one or the other, but the choice is driven by the noise. But that's still a decision of what and not when.
Okay, thank you. Thank you very much.
Okay, thank you. We have two questions from Tim Higgs, which were actually the first questions that were asked here. And he basically asked about the role of self-sensation when we talk about readiness potential. So he specifically asked, in order to understand issues around RP, conscious awareness, and experienced intention, we have to have an understanding of the nature and role of what he likes to call the self-sensation. So what would you say about our current, and we should add still limited, understanding of the self-experience in both the neural terms and philosophical, but particularly in neural terms? And then he added one more to that, what you might say about the role of self-sensation in the perception action cycle?
So I'm not sure if by self-sensation, he's talking about proprioception.
Probably something more broad is my guess.
Yeah, I understand it is a broad question, but maybe Tim could clarify in chat, or if he wants to, he can also raise his hand and I would give him word. Yes, so Tim, you should be allowed to talk now.
Yeah, hi everybody, and thanks for taking the question. This is a very general question, but behind all of this conversation are some assumptions or lack thereof about what is the nature of the self-experience. Walter talked about, but I don't have any control. Well, what is this I that we're talking about? And I understand that that's not a question we're close to answering, but it's a very important question because the I sensation, the agent, the experience of agency has some role. And so when we talk about free will or will, we're making some inexplicit assumptions about the nature of the agent. And we're used to thinking of ourselves as very firm I's, but the neural explanation for what the self-sensation or the I experience is still missing. And I just wondered whether you had any thoughts about that mysterious question.
I mean, it's a good question, and it's one that I've thought some about, and even tried to experiment on. At least the idea of the I in being extended into the body. So the idea that, you know, we don't know what the I is, where it is, but to move from the naive idea that the I is somewhere positioned in the brain to the idea that the I is embodied and encompasses the entire body, and that the actual decision to move, even the decision about when to move, precisely when to move, is not just made in the brain, but it's sort of a collaboration between the brain and the body. And that there's some evidence, for example, that you can read out the decision-making process leading up to movement from the muscle. That is to suggest that the motor system is not just forming a decision and then transmitting it to the muscle, but that the body and the motor system work in tandem in order to make those decisions. So that's, I guess I'm answering your question with another question, but there is at least this idea that the I encompasses the whole of not just the brain, but the brain and the body, that it's an embodied I.
Yes, I mean, I would definitely agree with that. The brain isn't separate from the body. The brain is one part of the body. The whole, there's as much feedback from the extended body system to the brain as there is in the other direction, for sure. And I understand that we don't have an answer to this question of I, but it's certainly involved in the question of agency and will. And my sense is that the experience of self, if you take an infant, you know, observing its waving hand that's out of its control, there's a development of the sense of self and agency that's a critical part of what I would call the perception action cycle, which is, you know, basically what we're talking about.
Yeah, well, I don't think I can say much to the larger question. I mean, I think the embodied view is certainly worth exploring more. I think, you know, one thing that we know is that if you interrupt people at various times, I think it's Patrick's work, and ask them, were they about to move or did they feel an urge? That correlates with the readiness potential, or the, you know, individual depolarization. And so there seems to be some kind of access to that whether, you know, the urge is reflected in the readiness potential. So I think that there's, you know, I don't know whether that fully answers your question, but there is some kind of, I don't want to call it perceptual access, but there's some sort of relationship between those signals and the experience of being an agent. And I think we have a lot more to learn about that.
Yeah, I think for my part, to be honest with you, it's a really good question. It's a really difficult question. I think that the work that I've done doesn't really speak to it very much. And in fact, it's maybe a question that I've wittingly or not kind of evaded just in order to get the work done that I did. And so, yeah, I mean, my view on that is nothing radical. I think my view is that the brain infers the I based on what it can predict. So if the brain can predict it, then it owns it. And that maybe isn't really a theory so much as it is a starting point for it. But you know, that's as much as I can really, I think, add on that topic.
Yeah, thanks. I didn't expect a definitive answer, but I was just wondering what your thoughts were on that whole subject. But thank you.
One other thing that I want to say is that, you know, when you are being an agent, you are aware of your agency, but I think in a much more transparent way than the kinds of experiments certainly that Libet did. You're not aware of the contents of your conscious state or your intention as such. So the kinds of experiments that ask you to report on the nature of your intention are asking you to do something that's not what you do when you're acting as an agent. And typically what you notice, when you really notice your agency, is when it fails, when there's a discrepancy between your action and intention and what happens. And I think that's one of the things that has tripped up a lot of philosophical interpretations of the experimental stuff, because I mean, this was my criticism of, you know, measuring the consciousness of intention. Consciousness of intention is not the conscious intention that we need when we reflect on our agency. It's not like when I come upon a red light or a light that's about to turn red that I'm, you know, aware of my intention as such to stop or to decide. I'm just doing it. I'm deciding, and I'm aware of the thing out in the world, not the thing not my mental state.
But Adina, may I just point out that you're using the terms you and I as if they are firmly defined, but they're very nebulous, and we don't understand what role, and that's what we're asking about in questions about will and free will. What is this part of the organism's experience that is conscious awareness in the human primate?
Yeah, I mean, I agree.
Adina,
I don't know that I'm using them as if they're well-defined, but yeah.
Sorry, Adina, before you react, or if you want to react, I would like to ask you maybe to do it briefly, because we are already past the 90 minutes mark.
Okay. No, I'm fine. We're good.
Okay, thank you very much. Thank you, Tim. Thank to all the speakers, all the attendees, and all the panelists. So unfortunately, we have several more questions, including one thought-provoking that I actually wanted to end with, which was from Uri. So I guess we will have to leave it for another meeting. So thanks to all of you. Thank you for attending. Thank you for a wonderful speech. Again, I would clap if I had the icon here. So I would like to conclude it here. Thanks again to all of you, and goodbye. See you again later.
Thank
you. Thanks very much.
Bye.
Aaron.
Goodbye.